Well, this works out really well. It's on my way home from Blue Planet, stopping by campus here. I founded it in 2012. I'll tell you more about the company, but part of the impetus to found Blue Planet was I was at a Gordon conference on biomineralization, which is my field, and I've taught it, I don't know, here on campus since about 98 or something like that. And one of the guys presenting his PhD work had discovered this liquid phase of carbon that we hadn't previously appreciated, which over the last few years we've come to realize is really important in biomineralization, how clams grow and coral skeletons and things. It's called a liquid condensed phase. And it's in our blood plasma, it's in seawater, it's in drinking water, and it's the way blue carbon exists in aqueous solutions. And there's a new device called a nanoparticle tracking device, which is different than dynamic light scattering or anything like that, that allows us to see these things. And as soon as I saw that, I realized immediately it was going to really revolutionize the way we could capture and handle carbon. And he had a lot of opportunities, but he wanted to come and join Blue Planet, and he and a few of the other team of PhDs I got together are still there. What we do is we capture carbon dioxide and we turn it into building materials, and there's a few aspects of this. One is that we're not trying to purify CO2. There's a belief out there that there's something to do with CO2 if you could capture it. And the fact is, there's no use for CO2. It's just it's a great raw material, but purified CO2 has almost no value. You can use it for Coca-Cola, but very small amount. But over 99% of all the money that's gone toward addressing carbon has gone under this belief that it would be of value to us if we could capture and purify large amounts of carbon dioxide. And there's no value to it at all. That's why the only thing they can think to do with it is pump it into the ground as a waste, which is very expensive. And so, fundamentally, the whole concept that we need to go out and purify a bunch of CO2 and have pure CO2 is, I'm sorry to say, it's just a complete waste of time and energy and hope and everything. There's nothing to do with all that CO2. We can use a little bit of it for enhanced oil recovery, and then it's going to come back out of the ground. So a key aspect of what we do is we don't purify CO2. We just convert it to carbonate. We're not trying to purify anything. None of the energy associated with purification. We don't do any of that. A big aspect is if you're going to capture significant amounts of anthropogenic CO2, and by the way, I do have all the questions written down, and I'll address the questions. I'll zip through the slides sort of fast. You need something that's going to take a few tens of billions of tons a year of CO2. If it's taking tens of millions of tons or hundreds of millions of tons, it's not even going to be a blip on the climate curve, right? So, to just put it in perspective, the largest carbon sequestration project in the world today is being developed by the province of Saskatchewan, by Sask Power. And their goal over a few $1 billion of spending over a few years is to sequester 1 million tons of carbon dioxide. So there's 1,000 millions in a billion. And we're talking about 10 to 20 billion tons, right? So you need thousands of these $5 billion plants with places to inject it into the ground with the money to pay for its monitoring and insurance over decades or maybe centuries to even do it. So you can almost ask the question, why are the Canadians spending $5 billion And I don't have an answer to that. You know, Senator Dorgan spent $5 billion in Illinois on the FutureGen project before they gave that one up. And they're all trying to purify CO2 and inject it into the ground. So the point is, you know, however you remove CO2, you better have something to do with it once you got it. And other than the movement of water, it turns out the movement of rock is the largest mass material movement on the planet. There are about 50 billion tons of rock mined and moved every year in poor countries, rich countries, tropical countries, Nordic countries. The whole economy runs off concrete and building materials. So first of all, you need a place large enough to put that much CO2 that's actually going to make a blip or actually cover most of anthropogenic CO2. The second thing is there's tons of great ideas about what to do with CO2, not many at a scale that could be significant. But if there's no way to pay for it, it doesn't really matter that much. If you have to create money that doesn't exist to go pay for it and create a tax, and if it were something like sulfur dioxide, which was handled beautifully by the Clean Air Act through a cap and trade type of system, we handled acid rain in the Northeast in a beautiful way. But sulfur dioxide exists in hundreds of parts per million in flue gases. In the flue gas of a coal-fired power plant, CO2 is at 150,000 parts per million. And there's not enough money in the world to tax it. If in Copenhagen, the Chinese told us that the developing world was going to have to pay them $100 a ton to mitigate their CO2. And they need to mitigate 5 to 10 billion tons of CO2 a year. So $100 times, say, 10 billion is a pretty big number. There's just not enough money to do it anyway. So the whole concept that we're going to tax, we're just going to add CO2 like another pollutant to the list that, NOx, SOx, CO2, we'll tax it, people will stop emitting. It's not realistic. It's never going to happen. It can't be treated just like another pollutant. So if you're going to actually do something that's actually going to work, there has to be money to pay for it. And there's every country in the world, from the Congo to Australia to Mongolia to Russia, is paying for rock today. And it's important in the sense that the purchasing power of government is probably the greatest lever governments around the world have to actually do something about climate change. I was at Copenhagen. I helped with writing the cement section of the Copenhagen Treaty and all that. I've seen how this process works. But, in Paris, there's this wonderful treaty signed. But fact is, if you looked at the science issue right after Paris, they pointed out that even if all the countries fulfilled on their pledges, by 2100, we're over 100 billion tons of CO2 going into the atmosphere, compared to today, which is just under 40. That's if everyone fulfills their pledges, which it looks like there's almost no way they're going to fulfill their pledges. So those mechanisms, it's hard to see how they could be effective at actually having any effect on climate change. What the editors of Science did say was that the use of fossil fuels would keep increasing through the century, which, despite what's happening in North America and Europe, they absolutely are going to. When we talk to Chinese partners all the time, they have no concern of CO2. Largest power companies in China, it's not even on their radar screen. They're concerned about soot because it's a visible pollutant. They're not concerned about CO2. According to them, there's no incentive coming for them to mitigate their CO2 in India and other places. So what the editors are saying is the only way to really do anything if we look at primary energy use is to do carbon capture and sequestration on biologically derived fuels, both fossil and modern fuels, and capture that. And by taking out this wedge, we might actually have a chance. And they conclude that that's probably the single most important thing that would need to be done to actually have an effect on climate change. And that assumes that we go renewables, a little more nuclear and everything. So what we're doing at Blue Planet is we've come up with a way to rapidly deploy units to go out to bioenergy plants and fossil fuel plants that are putting off a lot of CO2 and convert the CO2 into carbonate and then make that into building materials. What we're deploying right now is a modular unit that's manufactured by one of the largest manufacturing companies in the world that has a presence all over the world. But it's, call it a 2 megawatt module, and that means it'll take 2 megawatts of coal exhaust and convert it into rock that can be used in concrete. A key thing about it is that if someone comes out and invests in this capital equipment, they'll make a good return on their investment. And that's really where all the funding needs to come from to actually address climate change. There's not enough money in government. You can't print enough money to pay for this just because it's the right thing to do. And this is especially true in Asia and other places. So each module takes about 25 tons of CO2 a day at a 50% capture rate and produces about 40,000 tons of rock a year. There's economics associated with abating the air emissions, selling the product. And just to put in perspective, to separate CO2, like Kemper County or FutureGen or in Norway, or just separating CO2 from flue gas, the capital cost of the equipment can be $4,000 or $5,000 per kilowatt. So for a 1 gigawatt plant, that's like $4 to $5 billion. It's never, no one's ever going to pay for that. And it can take 40 to 50% of the power from the power plant just to separate CO2. So being able to do something at $700 per kilowatt is really inexpensive. The basic system takes in raw flue gas, captures CO2 from it, makes rock, which is in red there, sold for aggregate. I'll talk about that. It uses routine rock materials to reform a capture solution, and it regenerates. And it's based off a lot of experience in this area. Right now, if you go up to the San Francisco airport, they're building a new terminal. And if you look at the cast-in-place concrete there, concrete materials consist of Portland cement, fly ash, blast furnace slag, normal weight aggregate, which is rock, and lightweight aggregate. And all the lightweight aggregate, which is on all the ramps and things in the airport, are they have to be Blue Planet aggregate. There's no known equal. They're trying to be the greenest airport in the world, and a lot of the other airports are following suit in that. And I'll explain why a carbon negative material is so attractive. But the whole other side of this is in the built environment today. Historically, we've been focused on energy efficiency, like the lights and the heating and all that, in terms of being responsible for the carbon footprint of the built environment. And of course, lights and heating are driven by electricity, which creates CO2. But there's an architect named Ed Mazaria who spoke to the UN about this, that he has a movement called Architecture 2030 that says by 2030, all buildings are going to be net carbon neutral in their operations. And normally when you looked at the carbon footprint of a building, most of the carbon footprint was due to the operations, due to the heating or the lighting or something like that. About a third was due to the embodied energy in the materials, and a little bit due to the construction of the demolition of the building. And but if we get that operational carbon footprint down to zero, like Ed wants to do, what's left is the embodied energy of the building. And in any building you go to, almost in the world, the big part of the carbon footprint is the concrete. Secondarily, it might be the steel. But it's not the carbon fibers or the paint or a lot of the things that get marketed as green products. It's the concrete. And if you actually just look at the concrete alone, you can assess the carbon footprint of a building. So if you take the new Apple campus, for example, they had 5 concrete ready-mix plants down there in a pile of rock aggregate that was 11 stories high. And the carbon footprint of the concrete wasn't even part of the equation, right? They were looking at carpet fibers and LED light bulbs and that kind of thing. So there's a whole new movement in green building to really understand the carbon footprint. It's not just marketing. But in terms of, well, you know, how big's this market? A couple years ago, there were 54 billion tons of rock mined. By the way, rock mining is all open pit mining. It's not shaft mining. You know, to put in perspective, coal, there's 5 billion tons of coal mined every year, 1/10 as much. And most of it's shaft mining, you know. So when you hear about mountaintops being blown off, that's usually not coal, that's rock that's being mined. If you fly into the Bay Area, you'll see quarries all around where there's huge scars on the hills. That's rock being mined. But even at $15 a ton, which is a low price, someone somewhere, governments mainly, are paying $15 a ton for 54 billion tons of rock. So this is the money that governments can use to actually seriously address climate change if they address it properly. That's where their muscle is. It's not signing treaties that there's no money to pay for. It's to take the money they're already spending and spend it in the right way, in a more responsible way. And instead of spending on open pit mining, spend it on rock that's made out of CO2 that prevent it from entering the atmosphere. You know, and this has been done before. California has a crumb rubber law. So if you're a pavement contractor and you want to bid on a Caltrans job, you have to have crumb rubber in your asphalt. That's recycled tires. And if you don't have recycled tires in your asphalt, you can't even bid on the job. Have you seen many old tires lying on the road around here in the last 10 years? In fact, we're importing tires from other states to put crumb rubber in the asphalt. See, that's the muscle of government. It's much stronger than signing treaties that no one's going to follow anyway. Anyway, we use a process we call a geomimetic process, sort of like biomimetic, but we grow our rock very similar to the sands that occur out on the Great Bahamas Bank. Those white sands you see, that's not sand that came from rivers. There's no mountains out in the Bahamas. You know, it forms in place from seawater and CO2 that goes into the seawater. And that's what we do. We take substrates and we grow artificial limestone right around the substrate, and we make it in a way that it's useful in concrete. Here's some pictures of some fine aggregate that's been coated. The one on the right is the actual aggregate we used at the San Francisco airport. The coating goes on the outside of the particles. We can take material from just waste material from a rock quarry and put it through the process and be left with a substrate that can be coated. And here's some examples from California and Florida where we've used different rocks in the process. And in addition to just regular rocks as our feedstocks, we can process materials from a variety of industries that are just waste materials. I'll answer a couple of the questions. We're working at coal plants where we're processing their ash, steel mills where we're processing their slag, alumina refineries where we process the bauxite ore, as well as to go into this rock product that we're making in the process. Right now we're making, the type of concrete we're making is called lightweight concrete, and it can be pumped up high. It's being specified now, in a lot of the large buildings in San Francisco where you have multiple stories and you're pumping the concrete up high and there's structural concerns, so you need a lighter weight concrete. This is it being pumped up on the new terminal at SFO. It's distributed just like regular concrete. Concrete plants, they bring in rock and cement and admixture and water and put it in cement trucks. There's no new supply chain. But just to kind of give you a feeling of why this can work is this is an average half a gigawatt, 500 megawatt coal plant. And it's in a part of the world where there's no value to capturing CO2. It's not California or Canada. It's like New Mexico, or Alabama or Michigan or somewhere where they don't have any carbon laws. So there's no incentive, no financial incentive to get carbon. But the plant can pay $300 million for a system. It'll cost them $120 million to operate it. And their revenue, even at $30 a ton, which is a low price, is $300 million. And they get a 78% return on their investment. Blue Planet is just getting a royalty per ton of aggregate per year on the system. The system is manufactured by the largest manufacturer of this kind of equipment in the world. And I'm going to run through these kind of fast. This is a coal plant. Here we are at a cement plant. Again, no incentive of capturing CO2. They spent $80 million to purchase the equipment, almost $40 million to operate it, and they have an annual revenue of almost $100 million. It's a natural gas plant. Natural gas is much more dilute. It's 3 to 5% CO2, so there's a lot less product produced. And again, it's a good investment for them. But as we all know, there are carbon prices in a lot of the world, and I've retreated to California and Canada right now until the rest of the world catches up, because when you talk to anybody in Canada, they're like, great, let's do this, from all levels. To some extent in California, once you step over the California border, they haven't even heard about CO2. And it's a complete, unless they're shipping power into California and paying a tax, a surcharge. A lot of people say, oh, we don't have any coal in California. Well, look on your PG&E thing. It'll list coal, renewable, all that, and then at the bottom it'll say 18% other. At the coal plants out in Wyoming, I say, well, who's buying your power? And say, oh, we have contracts with Long Beach, Riverside, Modesto. That's where all those coal electrons are coming. But anyway, the point is, even if you add on the California carbon tax of $14, it's about the same. It doesn't really affect the overall investment for the person. So, it's hard to explain, but you need hundreds of millions of dollars and billions of dollars to make this happen, and it ain't coming from the government. It's not going to come from the people purchasing the power or the cement or the steel. But it'll come from the equity dollars people will invest in these plants. You can't do it with venture capital. I've been there, tried that, raised a few $100 million. There's not enough money in Silicon Valley to even begin, even a little bit, to approach this problem. You see, there was a a family office meeting out in Pescadero over the weekend, and all these billionaires are here and like, oh yeah, I'm going to fix the world. You know, they don't. You could put all their checkbooks together, and you couldn't build 2 or 3 plants. You know, you have to access the kind of capital that's not in the hundreds of millions, but billions of dollars to build all these plants, to do this anywhere.
You've got me very curious. So part of this class is figuring out how to make profitable companies that help the world, right? And you've pivoted from a previous company, Calera, which was making, I think, similar types of materials, but clearly you found something that's far more profitable. So that's one thing I'm curious about. And then another is, you're talking about really harnessing the power of the investment governments need to make in infrastructure anyway, and using that instead of, you know, a different kind of policy. But it seems to me that you're able to embed yourself in a policy of, hey, airports are required to have, asphalt is required to have rubberized, you know. So can you say more about both of these? How this is better than the Calera a few years ago, if it is, it seems like it probably is. And how one with a different idea, you know, going into a different space would be able to harness this power of governmental infrastructure investment that seems to be driving you. These are both so key to what you're doing.
Well, Calera made cement. We're making rock, so it's different technology, different company. But yeah, I mean, we in Silicon Valley were arrogant enough, you know, with Google and all that, that it's just another problem, and we're smarter than everybody else, and we'll just throw money at things. This is way too big for Silicon Valley. There's not, you could put all the money in Silicon Valley together, it wouldn't have any effect on climate change. You know, it's not a startup company thing. You know, I mean, we're talking changing the fabric of the infrastructure of society, not just North American and European society, but a society that's being emulated. You know, they have 8-lane freeways in China now, you know, and that's not going to happen with our startup thinking. You know, it's getting into the basics of government. You know, when you go to the gas pump and you pump gas, you're paying 8 or 9 cents, I can't remember, in a gasoline tax per gallon. And all that money goes to Washington, D.C. It's a federal gasoline tax to the Department of Transportation. And then it's doled out to the states. So California gets $11 or $12 billion a year just to buy rock and other materials. That's how we're going to really do something, if governments around the world wake up and realize that they already have the purchasing muscle. So I'm going to run through these. And we've already kind of addressed, you know, if you just wanted to separate CO2 and inject it into the ground, which is what 90% of everyone working on this problem is working on right now, because there's money to do it, even though there's no future in it. You're going to use 40% of the load from a plant, so you have a 1 gigawatt plant. You're going to use 400 megawatts just to separate the CO2. You're going to spend a ridiculous amount on the capital equipment, and then you still need to transport and monitor and insure the carbon, and there's no revenue from it, it's just a cost. And that's really different than spending less money, taking less parasitic load off the plant, and making something that governments are already buying in the first place. And I'm going to move ahead so we can get to the questions. This is an example of a product we're working on. If you go over to Home Depot, you'll see big pallets with stacks of concrete sacks, and most people say, oh, well, you know, that's not a big deal. Well, actually, over half the concrete poured comes out of sacks. And if you go to Mexico, 80% of the concrete comes out of sacks. You can't order a concrete truck in Mexico City and expect the concrete to be delivered because of the traffic. Or India or Indonesia. Indonesia is the 4th largest country in the world. They don't have concrete trucks. You know, you put a ready mix plant right on site. But this is an interesting product. It's 2/3 more volume, than a regular sack of concrete, so it weighs 80 pounds instead of 60 pounds. And the carbon footprint of that sack of concrete is about 40 pounds per bag. If you brought that up to how much is that per yard, it's about 1,000 pounds of CO2 per yard. It's about half a ton of CO2 per yard of embodied energy in that concrete. And it's funny, one of our friends and advisors built the Bullitt Center up in Seattle, which is considered the greenest building in the world. And while he was here at Stanford, he invented Earth Day. So this guy's, an environmental god, right? And someone said to him, well, what about the carbon footprint of the Bullitt Center? Of the concrete. So, well, that wasn't counted, because we're looking at the lights and all that. So it's just a new nuance to thinking about green building is the embodied energy. So if we just replace the coarse aggregate in this concrete with the Blue Planet aggregate, it gets it down to carbon neutral. So a yard of concrete is now negative 76 pounds of CO2. Okay. If we replace the fine aggregate, meaning the sand, we can get it down to negative several hundred pounds. And if the cement in the concrete came from a cement plant that has a Blue Planet system on it, so it's not putting out all the CO2, it goes, negative half a ton or so per ton. So if I'm placing 10,000 yards of concrete, instead of 10,000 yards times half a ton, it's 10,000 yards toward times 0 or times negative half a ton. So the built environment, instead of geologic reservoirs, becomes where we're sequestering the CO2. And the built environment that on day one of a building has a carbon bank account. And it may never even come up to carbon neutral in its whole operational lifetime because it's so energy efficient. And you talk to CARB, say, well, you're developing protocols so Shell Oil can inject 18,000 tons of CO2 into the ground in Southern California. Could you develop a protocol if we put CO2 into the sidewalk where we get the same kind of credits? And hopefully that's where the environment's going to go is, even if the state of California, we import 400 million tons of rock a year to this state. A lot of it comes from British Columbia. When we're up doing the San Francisco airport pour, they have a marine terminal up there, Central Concrete does. And all these barges from Orca aggregates in British Columbia are coming in dumping limestone that we're exporting at a huge carbon footprint to build the airport. And if you create the rock locally and use it locally, you're not transporting it. And rock weighs a lot more than cabbage in terms of, locally sourced materials. So it makes a lot of sense to make the rock. But I do want to mention, just for the students, that the biggest part of any effort is the team you build and the people behind it. And, like in all my companies, the management group that I've put together, former president of energy companies, people that have built plants with me before, former CEO of one of the largest construction companies, guy that was director of finance at the Department of Energy, the guy who built the largest renewable energy fleet in the world. So it's really helpful to get the brains behind you. Our scientific advisory board, from Don Kennedy to, Gordon Brown here at Stanford. These are people that have been working on these problems for a long time. In the built environment, people like Roger Platt, the current president of the U.S. Green Building Council, David Gottfried, who thought up the idea of LEED and the U.S. Green Building Council when he was here at Stanford in 1968, founder of the U.S. Green Building Council, another former president of the U.S. Green Building Council. Getting that kind of advice. And also, in this, on the government affairs side, Leo DiCaprio is a famous actor, but he's also a very influential climate activist, and he can he can call up heads of state and get meetings. So he's an investor, but he's also active player in what we're trying to do. Durwood Zelk wrote the Montreal Protocol. I met him when we were writing the COP 16 treaty up in Norway, and he's been helping us. Dan Tagliarini ran the General Services Administration, which is all the federal holdings. It's the largest real estate portfolio in the country, and he made the whole thing. That's why you have to have LEED Platinum buildings, all federal buildings, because of what Dan was doing. So I guess to close, I'll just say that limestone's been around for a while. There's nothing really different about turning CO2 into limestone. That's what most of the carbon on the planet is in limestone. So there's a few 100 million tons in the whole biosphere. In the atmosphere. I think about 400 billion tons in the atmosphere. There's a few thousand billion tons in the biosphere. And I think in the hydrosphere, there's a few tens of thousands of billions of tons. But in the lithosphere of the Earth, there's about 70 million billion tons of carbon. So essentially all the carbon is sitting in limestone. It's not in the atmosphere or in trees or in the water. It's sitting in limestone. So it's a pretty normal thing to do. And it's really interesting. You look at the history of the Earth, the times when we've formed the most limestone, and limestone is nearly 100% the fossil remains of ancient marine organisms. All the times where, like the Austin Chalk, the White Cliffs of Dover, CO2 levels when these rocks were formed, and these are just coccoliths, which are little plants in the ocean, were about 7 times what they were today. So, in general, the more carbon around, the more carbonate minerals have been forming. So it's a little different than the way the popular media discusses CO2 and all that. My PhD was on how corals form, and I'm very familiar with the physiology of all that, but it's a lot more complicated than making up a jingle like ocean acidification, because that's really not what's happening at all. But anyway, let's hit these questions. What are the major challenges of CO2 mineralization technology? Well, the most important one is scale. I don't think doing something that's going to mineralize a few million tons or a few hundreds of millions of tons of CO2 is really going to make a difference. And so you're working in the billions of tons. And to make mineral, you need all the constituents of the mineral to go into it. So CO2 is one of the constituents. But you also need calcium, for example, and magnesium. And so a major part of it is sourcing all the raw materials. And it's hard to explain. I was at a coal plant in the middle of Wyoming a couple of weeks ago with my guys, and we were driving around, and we crossed this train track to look at some stuff on the other side. And while we crossed it, this unit train with 110 cars of coal in it came by at like 3 miles an hour. Well, it takes more than a few minutes for a 3 mile an hour 100-unit coal train. And this was at a mine mouth coal plant. So this was only about 1/3 of the coal they were going to use that day. And it's just overwhelming. You look off on the horizon, and it's just coal cars. And it wasn't even all the coal. And, next day in southern Wyoming, same thing. We were at a cement plant in Alberta, and they bring in 330 train loads of limestone a week. And they grind it all. So you have to think at the same scale this stuff's happening. In the, sort of the clean tech module or mode in Silicon Valley is, okay, I'm going to make a little biofuels plant, and then I'm going to scale it up and all that. And I think the main thing is you have to think at scale from the very beginning. And I've told all our people, I don't want to have any equipment that's not already made by somebody else, that's not an inventory by 5 different vendors, you know. Because to scale, you have to get out there and deploy rapidly. Part of our modular approach is when you retrofit into a coal plant or a gas plant or a biofuels plant or whatever, you want to have minimal disruption, minimal permitting time. You want to be able to move things out if the plant shuts down. You know, here in California, we're going to be shutting down a lot of our power plants. It's not that we don't need the power, it's that they're going out of business because the solar is just making it impossible for them to stay in business. So we'll be bringing more coal power in from other states at nighttime. And so you have to think this plant may not be here in 5 years, and if you're going to put something in, you need to be able to pick up and move it. How is Blue Planet's carbon neutral or carbon negative concrete in terms of strength, durability? Is it similar to standard concrete? Yeah, we have a full concrete testing lab, and we've obviously passed all the ASTM standards. And we don't actually sell concrete. You know, we've been using Central Concrete, which is the U.S. concrete affiliate, which built Levi Stadium. They do a lot of work here on campus. They did the PUC building in San Francisco, the Bay Bridge deck, other things. In one of my classes, we talked about sequestering carbon in serpentine rock. Is this the same technology? Is pressure buildup a little concern when pumping the CO2 into the rocks below? Well, that's not what we're doing, but the geologic record has most of the alkalinity, we call it, on the Earth. So if you remember your high school chemistry, alkalinity is the ability to neutralize a proton. So it's something with extra electrons. So Harold Urey, who was a famous chemist, wrote a paper in the 40s about what's called chemical weathering. It's where, you know, rivers flow over rocks and interact with CO2 and neutralize the CO2. And he says the CO2 level of the Earth is buffered by the chemical weathering of silicate rocks, and all the alkalinity of the Earth is in the Earth, in the rocks of the Earth. And that's absolutely truth. And I guess one thing Blue Planet's figured out how to do is to really follow Urey's guidance and, you know, take the alkalinity of the Earth just from common rocks and neutralize all the CO2. The BP technology seems miraculous. Why isn't it more widespread? I think it will be, actually. You know, I've aimed things at rapid scaling. And as Leslie mentioned, this isn't the first time I've sort of built a large carbon sequestration plant. I built the largest one in the world down at Moss Landing back in 2009 using a different technology. And, you know, you learn a lot the first time around. I think by entering this agreement with this large manufacturing company that can make all the equipment, and by having a basic financing strategy where we're not going to, say, the venture capital community to raise money to build $100 million plants. I mean, that last company I raised $182 million in venture money and had about, I don't know, a couple $100 million in government grants, and it just was a drop in the bucket, you know, in terms of what you really needed to make something like this happen. By instead going out and accessing the project equity markets, which is how power plants are normally financed, by the way. You know, Exelon Energy doesn't go out and sell stock to build a power plant, right? They go out and get equity investors, and that's how this should be done. Is sequestering carbon currently profitable? If not, what are the largest costs, and under what circumstance will it be profitable? Well, that's sort of what I've tried to answer is, today it's absolutely not profitable. And the model is that the Department of Energy is going to pay for it, and the Swedish government and the Canadian government. And there's not even 1% of the amount of money or technology they would need to even begin to be successful, but they still keep spending the money. We're taking a different approach. We're looking at CO2 as a raw material. from which we can make profitable products that governments are already buying with the money they're already spending. State of California is spending, over $4 billion a year on rock today. Will whoever wins this upcoming election affect Blue Planet's mission and goals? We've already bailed on I'd say the lower 48, except for California. I'm spending 2/3 of my time in Canada. They've got a new prime minister up there that's really dedicated to what we're doing. I'm meeting with the First Nations that have a lot of if you wonder who's looking for those good IRRs, it's like the First Nations who are managing these huge funds, and are really concerned about the melting of the permafrost right now, because they can't even drive around in the summertime. It's all soup. At what rate would CO2 emissions need to be captured to have any meaningful impact on climate change? We have already gone over 400 ppm tipping point. Most developing countries don't have the infrastructure to limit CO2 production. So that's a great question. Developing countries aren't going to do anything to limit CO2 production. The poorer people are, the higher the interest rate. The first thing that falls off is the environment. And then add a war to that and just forget about the environment. People worry about starving before they worry about the environment. So, the grand illusion that we're going to have a global cap and trade system and Bangladesh is going to pay into it, I don't know what people are smoking. That is not going to happen, And you have to provide a solution to them. It's like, okay, Bangladesh, you're pouring concrete. You're spending all this money that you could be spending on this, on paying people to barge in rock, from Vietnam. Why don't you use your dollars in a more effective way? But a meaningful change, I think, is about 10 billion tons a year of mitigation. But when you look at the increase, CO2 is increasing now. It's not decreasing. It might be stabilizing in North America and Europe, but that's not what's happening if you looked at the science article around the world. It's probably got to start around 10 billion tons a year and grow to like 20 billion tons a year. Yeah?
What does that translate to in terms of building materials? And what's the global demand for those materials?
Yeah, so for rock, we're currently mining about 54 billion tons of rock a year and paying for it, transporting it.
And we can process the 10 billion goes to what? 10 billion tons of CO2.
Yeah, so 10 billion tons of CO2, you produce about 18 billion tons of rock.
With the calcium inputs as well.
Yeah, that includes adding the oxygen and the calcium to it. The molecular weight of calcium carbonate is about 100. The molecular weight of CO2 is 44. So 44% of each ton of limestone is CO2. Direct air capture strikes me as technology that is not very useful now. Much cheaper options currently available for decarbonization. Yeah, I guess I don't know what those are, but will be extremely useful in 2040, 2050, and 2060 once we have addressed the low-hanging fruit. Is this correct? If so, how can proposed technologies like CO2 mineralization bridge that time gap commercially in order to be ready 20 to 30 years out? I think everyone who wants to decarbonize the atmosphere is a hero. I guess, when you actually have to implement stuff, though, one thing I know designing these plants is the cost of the plants is mostly determined by the cubic feet per minute of gas you're bringing into them. So if you're bringing in gas from a coal plant, which is 15% CO2, 15% is 150,000 parts per million. The air is 400 parts per million, right? So it's like 1/400th, or so you'd have to bring in 400 times more volume of gas to process. So it would cost 400 times more to take it out of the atmosphere thing to, and you know, if you look at that 38 billion tons a year that humans are putting out, about 9.8 comes from coal plants, about 4 or 5 comes from natural gas plants. The rest come from steel mills, cement plants, aluminum refineries, and then the other half of it comes from transportation. And if we electrify transportation, but we're still importing coal electrons from Utah and pretending, you know, we're driving up Sand Hill Road with our Tesla that says emission-free power, but we're charging it with coal electrons every night. You know, it's not going to get us anywhere. But what I have seen with direct capture plants is they aim to capture about 1 million tons a year, and the cost of the plant is, you know, on the order of $100 million. So if you wanted to do 1 billion tons, you need 1,000 of these plants. 1,000 times $100 million. And that's not even before you get to the operational parasitic load, which is of that million tons, how many million tons did you generate just operating the equipment? And I guess with flue gas that dilute, it's probably about half, you know. So, but, you know, there's no doubt trees are one of the coolest ways to sequester CO2, you know. I mean, it doesn't get any better than photosynthesis, right? And if we could get the chemistry there, that would be awesome. Oh, I have this one. What do you envision the best scale for your BP products to be if all building materials in the U.S. were made in this way? Would the U.S. be carbon neutral? And do you see a limit to how much this could be done? Well, the U.S. uses about 2.5 billion tons of rock a year. So just with the current rock that we're making, we could do well over 1 billion tons just in the U.S. And I should know this, but of the 38 or so billion tons the U.S. puts out, it's a few billion tons. You know, a lot of that's transportation. So, you know, we could cut U.S. emissions pretty significantly, you know. Yeah?
Sorry if you mentioned this and I missed it, but what's the source of calcium that you're using?
The rocks that we bring in. So
You're talking about like steel slag and coal ash.
Right, yeah. No, it's a great question. I skipped over that pretty fast. Most of what we just bring in is just rock. And it's what we call unclassified. It's got all the fine powders that they dispose of and fill up the quarry, in addition to the big rocks that they gap grade to use in concrete. And a lot of that fine material is actually processed, and the calcium and magnesium and iron and other things dissolve out of it. But we also use waste materials. Like at the coal plants we're at, they have decades of fly ash piled up that the EPA wants them to remediate. And you know, some of the fly ashes are, you know, 40% calcium oxide, 15% calcium oxide, sodium oxide, potassium oxide, magnesium oxide. So we call it geomass, and it's meant to be vague in the same way when we talk about biomass. You know, in a biomass reactor, sometimes you might have switchgrass, sometimes you might have wood chips, you know, and you're adapting to a lot of different materials.
Fly ash has very high aspect ratio, small percentage of very high aspect ratio materials.
Yeah.
I would imagine, I don't know, building them into something else might be a good
Well,
thing.
every yard of concrete in the US, well, actually the world today, has some fly ash in it. It's very rare, like except with the LA school district and a few other places where they've outlawed fly ash. But, you know, there was a 10-year controversy about putting fly ash in concrete because it's a coal combustion product and, you know, all these other things. But they decided it would be a problem if you declared all concrete in the US a hazardous material, and you had to remove all of the concrete in the US, start over again. And you know, the reality is, you know, I used to make bone cement for orthopedic surgery and helped establish the EPA specs for bone cement. And, you know, I can put bone cement in your grandmother that's 50 parts per million lead. But in that operating room floor, it has to be 50 parts per billion. You know, so the FDA and the EPA don't talk. And then there are concrete experts in the green building industry who have no technical experience whatsoever, none, who are setting these standards. So it's kind of, okay. Discuss Blue Planet's work on emitter projects. We got a pretty great grant up in Alberta a few years ago, and so we're working quite a bit up in Alberta, both in cement and coal. We're working in Quebec. Quebec's carbon system is synchronized with California's, and Ontario just joined it. So you can earn credits in Quebec and sell them in California, or earn them in California and sell them in Quebec. They have big alumina plants up there because alumina uses a lot of electricity, and they have a lot of hydropower. But they still have to burn natural gas to generate steam. And they produce a lot of what's called red mud, which is probably the largest, ugliest waste in the world. It's piled up. But it's full of ions and alkalinity and other stuff. We're working at, like I said, in Wyoming and Utah, at coal plants that import power to California. So they're paying whatever, a $10 per megawatt hour surcharge to ship it over the border into California. So they're incentivized. I spent the whole company today with a large natural gas power company that has about 84 natural gas plants, a lot of them here in California. So for example, that plant that I built with down at Moss Landing 7 years ago, last year they paid $35 million in carbon allowances. And I think their gross, it's a merchant plant, it's not a regulated utility, their gross was like 700 million. So 35 million off 700 million starts to be a significant cost. So they're motivated to eliminate their CO2. Well, a lot of them have been interesting. In Mexico, we're working with a big steel conglomerate. And they teamed up with a large cement company. So the cement company is going to bring in the rock. They're right next to each other. We're going to take the CO2 from the cement plant and the steel mill. And then the cement company is going to distribute the rock too. So the steel guy doesn't have to worry about rock. Because a lot of them complain. They go, look, we've never worked with rock before, So if you bring someone in who knows that. The other thing we're finding is we thought we were just going to go out and independently finance these plants, which is what I've talked about a lot here. And there's clearly a lot of project equity financing, whereas it's just too big for venture capital. And what they're coming back and saying is, no, we want to own this. And if I'm a regulated utility, I'm going to put this through the rate base, take it to my PUC, which is unexpected. I understood the cement companies would want to own it because they're already in that business, because a lot of them are vertically integrated and they own not just the cement plant, but they own the quarry and the concrete plant. So they can distribute everything themselves. And that's really important. One of the concerns of emitters is, well, what if you can't sell this stuff? It's going to pile up. That happened at a plant in Florida where they were taking sulfur dioxide, converting it into gypsum. And they had a deal with US Gypsum for wallboard. And then the construction market tanked and no one was buying wallboard, and they had 40 acres of gypsum. And they were on a manatee preserve, and it was just a total nightmare. Have these efforts been received particularly by coal plants? If they're in Canada or California, you see big groups at meetings, shaking your hand like this, with smiling faces. If they're in Ohio, they may not return your phone call.
Is that all due to regulation?
Yeah. I mean, financially, the regulation doesn't really help the economics, but the reason you have to have a carbon price is that that's the only thing that's going to motivate emitters. And except creating a financial incentive. People are, this will be particularly true in China. If you create if governments say, look, Caltrans, Sacramento, Jerry Brown. Look, Caltrans. And Malcolm Dougherty, who's the head of Caltrans, would absolutely love to do this, by the way. From now on, all the concrete that we specified for the high-speed rail, it's going to be carbon neutral concrete. We're not choosing a winner. Doesn't matter how you do it, but it has to be carbon neutral. You've just created a huge market. I was with the folks at the high-speed rail, and they brought in the lady that's doing their carbon, life cycle carbon analysis. And I said, well, God, that's great. How are you accounting for the concrete? And she goes, oh, yeah, we've calculated all the truck routes, back and forth to lay the concrete. And I said, yeah, no, I got that. But what about the concrete itself? Just, oh, we don't count that. If you look at the CO2 footprint from the concrete in the high-speed rail, right? That's all going to happen when you build it, right up front. And then you say, well, if we look at the transportation savings by taking the train instead of driving a Prius or something like that, it's not a very clear picture that you're going to improve CO2 emissions in the state of California, at least in the first decade or two, by pouring all that concrete for the train to go over. Are the costs and energy requirements of carbon sequestration economically feasible for coal? Well, with the current approach, not even remotely, right? I mean, so, all the bankers are always talking about, what effect is this going to have on the levelized cost of electricity? And, you look at utility scale solar thermal and all these other, nuclear, natural gas, other solar options, and they're all really expensive. But to actually sequester carbon dioxide and then find these fields and build pipelines and inject it underground and monitor it and insure it, makes electricity extremely expensive. So I think right now, if you take the policy literally, even under the president's Clean Power Plan, where we would retrofit coal plants to have the same emissions as natural gas plants, they really don't have the technology to do it. And in fact, we got started at a plant down in Tampa Electric Company, Big Bend Power Station, which is one of the biggest plants in the Southeast. And we'd already started our construction. We'd cut a hole in this Herzig, the flue stack. We'd built piping, and they were acquired by a company that's more into natural gas, and they decided just to repower the whole station with natural gas, even though they don't have the natural gas. They're going to have to build an LNG port there just to bring natural gas in, So coal is essentially going away right now. And the thing is, it's not going away in most of the world. It's only going away in the United States. It's not going away in Europe. Germany is building new coal plants, right? Because they're out of nuclear now. So it's a tough situation. See, I read up about Blue Planet. Everything seems well and good, except for I've never heard of Blue Planet before. After creating a technology, how do you overcome the challenges of mass implementation? Well, I'm a little bit, this company I built down at Moss Landing, I had a lot of venture capital investors who were very helpful, but I think their descriptions of what we were doing was sort of coming out too early, too much, more, over-promising, and it was very difficult to be in that situation, so we haven't done anything. We'll talk to the press sometimes, but it's very limited. They quoted me in The Economist a couple weeks ago about concrete. We had something in National Geographic over the summer, a couple page spread. But we really haven't, we've tried to stay low under the radar screen because there's really no benefit to having publicity for what we're trying to do, because those aren't the people that are going to make the decisions, And there's just more negatives. You think everyone would be in favor of figuring out an actually implementable way to actually address climate change, but it's not quite that way. So we're just laying low. But that was the last question. Were there any other questions? I see we're right on time. Yeah.
Can we just double click on the financials? So 99% IRR.
Yeah.
Why isn't everybody beating a door? That's an annual 99% return. Does it include all the costs of marketing? Because if you've got that model, people should be beating the door down, funding everything, writing a check.
Yeah. Well, that's what I'm saying is that. So the private equity investing community has been uniformly ready to finance these things. But like I said, a lot of the emitters are saying, maybe we don't really want to be in the rock business, but we'd like to own that. And so all the sites I talked about, we have some kind of relationship where, they're owning it, we're owning it, somebody's owning it. Yeah.
There's no problem with it. I think it's a non-sequitur. But you're saying the problem is the money, but on those numbers, the money should not be the problem, right? So I'm not quite sure. Just double click.
Yeah. So I'm differentiating between, say, a venture capitalist who's managing someone else's money and getting paid to do that, and they're going to cash out that money in 3 to 5 years or 7 years when their fund's done. And project equity investors who are looking for long-term returns at a decent rate with a lower level of risk. So they're not going to make 1,000 to 1 on this investment, but they may have a 30-year consistent investment. It's more typical of the way these things are financed. And that would be true when the owner of the emitter is putting on their balance sheet too.
So what scale have you achieved to date? How many tons of CO2 have you taken out of the air today?
We're just building these plants, and the San Francisco airport, that one pour I showed you was, probably 50 tons or something like that. But the next step up is these 2 and 10 megawatt modular facilities, which each modules, they're doing 25 tons a day. So, if you have 5 of them, that's 125 tons a day. It's really interesting. We don't, a lot of people say, well, how much does this cost per ton of CO2? Because that's the metric. If you're thinking of it as a waste and you're just going to inject it into the ground, you just want to know what your cost to remove the waste is, right? And we don't even think about it that way. We say, how many tons of product can we get into the green building world to sequester CO2? Because if any of the agencies that actually, there are these protocols that have to be validated by third parties. If we're going to say we sequestered 1,000 tons of CO2 in this concrete pour, we have to be able to prove that, if we're ever going to get any kind of credit for it. So we're both financially and from a carbon counting point of view, we're focused on how much got sequestered into the built environment is the way we think about it. And what is the cost per ton of rock would be the way we make our decisions. Yeah.
How do you guys approach clients to get the modules installed? And also, does Blue Planet also work on the part getting legislators to implement this renewable concrete? So for the San Francisco airport, was Blue Planet directly involved, or was it just indirect?
Right. So if you mean clients by people that are buying carbon negative concrete, like with the San Francisco airport, they hired a consulting firm to tell them how to make the greenest airport. And as you could see, the elite of the green building world are also part of Blue Planet. So, even if we were to produce 10 million tons tomorrow, it would all be gone and we'd be out, because everyone wants to specify carbon negative concrete, right? So from the product side, I don't know if we could ever satisfy the demand, because from the built environment point of view, concrete is the 900-pound gorilla, and if you can eliminate that and have carbon neutral buildings, you could revolutionize the whole built environment. From the emitter side, like I was saying, Southern Company has no reason, Duke Power, they have no reason to even be interested in any of this, but a company in Canada or California would. On the legislative side, federally, the main thing is the federal highway bill. There's a lot of other avenues, but surprisingly, who's really good is the Department of Defense. And what's different about them is when they want to do something, they just do it. It's different. And so the Navy said, we're going to have all our airports carbon neutral by 2017. They're doing it. I mean, they're actually, it's not like maybe kind of, they're going to make it happen. So that's kind of been interesting. But I mean, the main lever, like I've been saying all along, the government has is not funding things. It's by just using their purchasing power, and using it responsibly. Yeah.
Yeah, you mentioned that a few times, so I was just wondering, is there like a policy drive to get governments to codify any of this into new legislation? And I'm just wondering, do you have a strategy on that, and what are you going to do in the future?
Yeah, we have about 6 people. One of my vice presidents is in Washington. He's an environmental law professor at George Mason, and he also used to work for the Portland Cement Association and the National Ready Mix Concrete Association. And we've gotten DOE grants together in previous companies, so we are working on that whole process. It seems to be a nonpartisan bill that usually gets passed. So, but there's a lot of concern about not choosing winners. And there's really no one else making carbon negative concrete. So even if you didn't say Blue Planet, but we are. Did that cover the first part of your question?
Yeah, I'm just wondering if there's any like specific laws that you're looking at, and if there's a long-term strategy to integrate more of this.
Yeah, it's the federal highway bill, which gets renewed every few years, and there's other versions of it. And then here in California, the legislator specifies like this crumb rubber material and all that. But we are spec'd in. We pass all the tests. You're not compromising safety or quality or durability or even price. So yeah.
What's the efficiency of the process? If you add the sequestration onto an existing power plant, how much extra power or power input does a plant require in order to produce the? Yeah,
that's a good question. I skipped over the slide sort of quickly, but so we call that a parasitic load. And that's one of the big things about what we're doing is we have a less than a 10% parasitic load, which sounds like a lot. It can be 100 megawatts on a gigawatt, but anyone else even coming close to this has got a 40% parasitic load just to separate the CO2. So yeah, nothing's free. That's for sure. I mean, and that's true. Building solar panels, huge carbon footprint. Windmills, big carbon footprint. Teslas, gigantic carbon footprint. It's just getting into that full carbon life cycle thinking. Yeah.
I wasn't sure in your timeline or in your roadmap of Blue Planet if you currently have customers that own this industrial equipment that's currently churning out these concrete, pellet editors, or if that's still slated in the roadmap in the future.
Yeah. So, like with this past company, Leslie was discussing, I hired 85 engineers, and we'd build everything, and we still had contracts with everyone. What I've done with Blue Planet is stay kind of lean and mean. We've got a bunch of scientists, and then we have an owner's engineer, which is a large engineering firm, that's engineering everything. But then we have a contract with this 190,000 person manufacturing company that's all over the world. So they do all the procurement and assembly of all the equipment. So yeah, we have signed agreements with our partners who are commercializing with us.